Yeah, in the last session, we have discussed about what are different, I would say, uh, subdomains in AI, such as ML, machine learning, deep learning, generative AI, and what are they, and how does the machine learns? Basic intuition, we have discussed, and few of the terminology that we use frequently in the machine learning, such as model and what are the parameters. And yeah, this much we have discussed. So as extension to this one, what we will discuss today is uh, this is important again. One is learning paradigms in machine learning. Just as a recap, what is AI? AI is building machines that can behave intelligently, at least if not up to the level of human intelligence, with some intelligence. It can be anything. And one more important thing that we need to remember here when we are saying that we are building machines that are intelligent, it may not be up to the mark like human intelligence. The level of intelligence, it may not be up to the human intelligence. It can be anything. For example, if you have built a system that can detect the temperature in a room and adjust its settings itself to make it more 20 to 24 is the comfort level of human, right? So if it is adjusting automatically, that is also an intelligent system that you have built. And for example, if you have built a customer churn pipeline that can predict the customer churning rate per month, how many customers we are going to lose per month, if you are able to predict it correctly, that is also an intelligent system that you have built. So everything, you don't need to think up to or at least on the level of human intelligence. Anything that is automatic and able to take the decision independently, able to take the decision and execute it independently, then that is an intelligent system. So that is one thing. And while doing so, we follow different approaches. Like we use some algorithms in just like in machine learning. We apply those we try to build intelligent systems on the structured data in machine learning. If it is unstructured data, we cannot do it with machine learning. We need to go ahead and use deep learning techniques. And underlying mechanism through which we make the system learn in machine learning, it is different from deep learning. Using algorithms, we teach them in ML. Using neural network architectures, we teach in deep learning. And in generative AI, again, it is completely different. The kind of use cases are the um, problem statements that we deal with in generative AI. It is different. In ML, it is structured data. In DL, it is unstructured data. In generative AI, we don't, what to say, we usually, these two, machine learning and deep learning, we use it to predict some output. But in generative AI, we use this technology or basically this models to generate new content. That is the main difference. So these two are fundamentally different in the nature of output itself. In ML and DL, output is the prediction, but here output is the generation. So that is why the name generative AI. That is important thing to remember again. So once we have this, next thing is how does the this one is clear. I hope. You have any questions on this one? How does the machine learns? Let me zoom in a bit. Learning paradigm. So how these are there are multiple ways through which we teach the machines to learn, right? But fundamentally, we can say that these are the few of them. One is supervised learning, unsupervised, and then self-supervised. One more is there, reinforcement learning. Sorry. Right. This is also one of the interesting one, but yeah, we will not be discussing too much on this one. This is out of scope as of now. And supervised, unsupervised, self-supervised. What are they? Is something like this. For example, I have a data set where let me draw it. The same customer churn data set. Let us say it is number of months active and number of complaints, and this is the prediction. Let us say output last call. Only two features we had. That is um, otherwise, to make it better, or to if you are confusing with this one, we can use some other use case like house price prediction. Let us say we have a data set. This is first column is something like area of the house, and the next column is something like number of bedrooms in the house, that I am writing it as NR, and then output is the price. So that data set consists something like this. First column it is representing area of the house, and second column it is number of rooms in the house, and third column it is price of the house. So here input features are the input variables are area of the house and number of rooms or number of bedrooms in the house. Then for a given area of the house and a given number of bedrooms, we need to predict the price. This is the problem statement here. For that, what we are giving as input to the model is this data. This, let us say, first for one data point, first data point, let me make it as something like area of the house as 1500 square feet and number of bedrooms as 2. Then price is something like 1000. It could be anything, just like. And then for the second data point, it is 1800 square feet and number of bedrooms is 3, and the price is something like 1200. So here what we are giving to the model as input is this kind of labeled data. That is, first these two columns are input and this is output. Then we are asking the model to learn the pattern inside the data. That is, it may come up with, since it is a numerical value that the model has to predict, we call this kind of use case as regression. I will discuss about that later anyway. So it may come up with some equation, something like 1.5 times of area of the house plus maybe 20 times of number of bedrooms or number of rooms is the model or the equation or the pattern that it may come up with. This gives us the price of the house. So here few things that I want to reiterate again. This is this equation itself, we call it as model. This equation, whatever you see here, this we call it as model. And these point parameters, these coefficients for the input variables. What are the input variables? Area of the house and number of rooms, right? So these coefficients of this input variables. We call them as parameters in generic ML terminology. And this one is output variable or target variable. So here what we are giving as input to the model, it is some labeled data. We have this input, these two inputs, and this is the output. We have these two inputs, and this is the output. So we are teaching the model that when you have these kind of inputs, you need to, this is the output that we have. When you have this kind of inputs, 1803, and this is the output. So we are clearly guiding the model. We are clearly supervising the model to make the correct predictions during the training by giving the output variables. We are not leaving it in the air. We are clearly telling the model that when you have this is the input and this is the output that you need to come up with. Your model or the pattern that you learn, it has to come up with this prediction. That is what we are telling to the model by giving this kind of labeled data set. Labeled data set is nothing but we have clear differentiation here, what is input and what is output. Then that is called supervised learning. And in case of unsupervised learning, we will not have the such what to say labeled data set. Labels are not present in the data, then that is unsupervised learning. Let us say you just have something like same customer churn data set. I think I have drawn it anyway. Let me go back. Let us draw one more time. Let us say we have the same data set, months and bill and something complaints. Number of months inactive or active, it can be anything. And number of complaints and the bill. If this is the data that we had, then if your task is to come up with who are going to uh, what to say churn for the next month, if some use case is something like that, for a given month, number of inactive months or active months and bill and the number of complaints, if your use case is to come up with a customer is going to churn or leave or not, then that is kind of supervised learning that we will do, because there we will have this kind of data, like for given value of something here and here, he is going to churn and this guy is not going to churn. If we have these labels here as output, then it is supervised. But what if I remove this? I have to do it from here. What if I do this? I don't give this as input at all. What I have is just these two, these three. Monthly, number of months active, and the bill, and also the number of complaints. This is the data that is the input given to us. And then if somebody asks, what are the something like you need to come up with two natural segments or the clusters that are present in the data set. Then you will be able to cluster them into two groups, which are will churn and another is will not churn, will stay back. This is clustering, we call it as. So here we don't talk about anything whether how many segments are the how many clusters of the customers we have in the input data set. We don't give it in the data set itself. We let the model to decide these two. And one more thing is you don't need to even tell about churning or not churning anything. You don't need to give it as input. Model will learn itself that if the data set is really clear and if the data set is really valid data set where it has clear pattern, let us say if number of complaints is this much, like the rules that we wrote in the starting, right? If the number of complaints is this much and the months of inactivity is this much and the bill is this much, then this customer is going to churn. If this kind of clear pattern is there in the data set, then model itself will learn these rules and come up with clustering, come up with some sort of segmenting the customer. It will learn itself. We don't need to give the model about for a given values of number of complaints 0 and number of months inactive 2 months and bill it is 0. Then it is obviously last month bill is 0 and he is inactive from 2 months and number of complaints is 0. So almost it shows sense of uh, not so interested in this service. So he is going to churn. This data point, there is no output or target variable that is present in the data set. Then this is unsupervised learning. We are not providing any output labels in the data set, just like in this case. Then it is unsupervised learning. And one more use case, let me tell you to make it more clear. Anomaly detection, we call it as. In anomaly detection, let us say you might have seen nowadays almost all the banks, if you do huge transactions like 1 lakh, then immediately you will get a call from the bank saying that this is the um, amount that you have transferred. Is that really you? Please confirm. So how they are able to make this? It is just using this one, like amount. If the amount is greater than something and the greater than some threshold value, I am writing it as TH, and the contact to which you have shared is the new contact. Contact is new, and the timing during which you have done the transaction, if it is unusual, maybe they are checking that also. Then we will have to track this. This is an anomaly. This is anomaly detection problem. So here also, like we don't need to give such whether this is an anomaly or not for a given set of, then the data set may look something like this: amount and to account means to account means to which we have transferred the amount, and timing. If these are the three inputs, then model will be able to come up with segments, or it will be able to classify for a given three values whether it is an anomaly or not an anomaly. This is fraud detection basically. So this is unsupervised learning. In supervised learning, we will have the output labels present. Output are the target variable present. But in case of unsupervised learning, there is no uh, output variable or the label present. This is one thing. And one more is topic modeling, we call it as. Same. That is also unsupervised learning only. Topic modeling, where we have some, let us say, 10,000 documents. Documents. We need to identify how, what they are about, like kind of what they are about. Some are related to like some 1,000 books related to arts, and 1,000 books related to engineering, 1,000 books related to science, something like that. What they are about. That is topic model. There are also clear uh, topics or the segments or the groups may not be present in the input data set. It is our model's duty, model's responsibility to come up with that groups. That is unsupervised learning. So these are the use cases. One is fraud detection, clustering, customer segmentation, topic modeling. All of this comes under unsupervised learning. Next one is self-supervised learning. So self-supervised learning, this is most important, and we use it in all the generative AI use cases. Self-supervised, as the name suggests, it is supervised. That is, output variable is present, but it is self, right? So how does what is happening here is, it is something like, imagine you are training a GPT model or any LLM for that matter, where you need huge amounts of data. If you want to create a supervised data set, it is not practical. You might have seen, right? Preparing training data for the GPT, particularly instruction fine tuning they do. Once they build the base model, I will talk about it later anyway. But yeah, this is the base model. Let us imagine after this, whatever self-supervised or supervised learning, or basically transformer architecture training is done, then that is base model. Once this is done, they do a lot of post processing also. One of such post processing step is instruction fine tuning. Why? Because this base model has two capabilities. One is language intelligence, language understanding and language generation. These two capabilities it comes up with when it is trained on transformer architecture. Language understanding and language generation capabilities. But it cannot talk to you like a human, or it cannot maintain the conversation. It is not trained on that. This is trained on basically next word prediction, NWP. Its capability is only that much. For a given text, if you give these two a lot of post processing. One of that post processing step is instruction fine tuning. In instruction fine tuning, what we will have is, because we wanted to teach the model to converse, basically to maintain the conversation, to talk to the people, humans like human. So there, what they do is they prepare question answer pairs like this. This is the question, this is the answer. This is the question, this is the answer. This data set they need to prepare. For that itself, OpenAI has spent millions of dollars, because it needs human annotators who can prepare these questions and answers. That is really costly. This is that too a small part of training, where it is post training. Imagine if you are doing this kind of creating data set for the main training part itself, transformer training itself. It is going to be really costly and not practical also. Preparing billions of a training data set, you like humans preparing billions of data points for training in transformer, it is not practical. So what they have done is they have come up with one very elegant and intelligent way of creating data set. Unlimited data data set you will be able to create. So we have huge corpus of data online in the web, basically in the internet. So you can take any text, something like uh, so I'm just asking some question, random question. For example, this is the text that you had. Otherwise, text. Yeah. So if this is the text that you have on internet, how they have prepared data set out of it for the next word prediction is you take this first word, that is this word, chat GPT, and then predict can. And you take this chat GPT can, and then you will predict may. And then make, you take chat GPT can make, that is till this point, 3 words, and predict fourth word. So here, the input was this data set. Sorry, this data, this much data we had. This is one. And out of this input, we are creating multiple inputs and outputs, multiple inputs and output pairs, and which are coming from the original data set itself, original data point itself. So that is why the name, this is the self part in self-supervised, and supervised is we are creating input and output here. This is the input, ChatGPT is the input for the first data point, and this is can is the output, next word prediction. And ChatGPT can is the input for the second data point, and make is the output. Because here the task is next word prediction that we are training here for the ChatGPT or basically transformer architecture or any LLM, right? That is the main thing. So when you have 3 data points, ChatGPT can make, then the output is mistakes. This is fourth data point. So it has the labels, right? This has input and this is the output. This is the input and this is the output. It has sorry. It is labeled data set that we are creating. So it is supervised data, supervised machine learning. But it is self. Why? Because we are creating one data point. Sorry, all of the inputs are being created from one data point. That is this one. Likewise, you can take any data point and then create multiple inputs and output pairs. That is what happens in case of self-supervised, and it has solved the biggest problem of creating human training data set for the transformer. So just to make it concrete, let me write everything in one somewhere here. Yeah, this is better. So paradigm, hope it is visible, right? First is supervised, unsupervised, self-supervised. And here, first aspect is labels needed. In supervised, it is yes. And in unsupervised, no, we don't need any labels in the training data set. And no, here also we don't need we don't need labels, but we will generate them or generates its own. And the next aspect is like few of the use cases so that it will be easy to remember. Like house price prediction or customer churn, whether a particular customer is going to churn or not, this kind of use cases. Unsupervised example is segmentation, customer segmentation, topic modeling, and anomaly detection. These are few of the use cases. And self-supervised is best example is GPT models, or for that matter, any pre-trained LLM. So these are the examples. Is this clear? I think reinforcement learning is different topic. Let me explain briefly what it is actually. In reinforcement learning, what happens is we have this something called as agent. This agent is trying to this agent will have 2 points again. There is let us say we are building agent to predict the next move in the chessboard, let us say. And this is the chess piece that it wants to move, our system. Then, and let us say this is an elephant, basically. So it can only move in the forward direction and that too in the straight direction. So if our model, the model that we are training, if it predicts this, this one, this one, then we will reward that agent. If it predicts this one, this part, then it is wrong move, right? So then we will penalize that agent. So there is an agent basically which tries to predict the movement of a chess piece in the chessboard. Then whenever it makes a correct prediction, then we will reward that agent. Whenever it predicts a wrong move, then we penalize it. So ultimately, this agent's goal is maximize rewards and minimize penalties. So if we are working on this kind of, we do the like this in reinforcement learning. This is another learning paradigm in AI. This is a different topic. So yeah, is it clear all of it? Basically learning paradigms.
Yes.
Yeah. So let us move on to the next topic. That is something related to the old one that we had done. That is, how does the machine learn? So let us discuss the complete training process that we do in machine learning through which machine learns. Mhm. Otherwise, let me go back to this one. New sheet. Yeah. And let us say this is the again house price prediction data set that we have. First column is area of the house, and the second column is number of bedrooms, and third column is something like age of the building, how old it is basically, and the fourth column is how far from main road, something like this. So number of bedrooms, this is fine. And one more, I want to introduce that one also here. It has just to make it color of the building, then it will be categorical so that I can explain. So finally, it is output is price of the house. So we can ask. These are the inputs that we had, are the input features, input variable, and this is the target variable or the output price of the house. So then here you can observe the values. It could be area of the house, it could be 1,000 square feet, and number of bedrooms, it could be 2. Area of the building, it could be sorry, age of the building, it could be like 7 years. How far away from the main road? It is just 2 kilometers away. Color of the building, it is gray, let us say, and price is something thousand and give. So here you can observe these input features, these first four, starting from area till how far from main road. All of them are numerical, but this one is categorical. So machines don't understand the text. It has to be converted into numerical format. There are multiple methods or the multiple ways to do it. One of them is one-hot encoding. We'll discuss about how do we treat the categorical variables, categorical features to make them machine readable or machine understandable format. But just I wanted to show that these are the numerical features and this is the categorical feature. And then now what happens is like this, we will have multiple data points. Number of bedrooms is 3, area of the is like 12 years. How far is 1 kilometer? It can be like white, and it is, let us say, 1500. So like this, multiple data points would be there. Now, what we do usually in machine learning, when we are building machine learning model is, we cannot use complete data that is present inside the data set for training purpose. First step that we do is we split it. We split it. Like, let us say, if I have something like 1,000 data points, out of 1,000, what I do is I split it into 800 and 200 or 750 and 250. This 800, I use it for training purpose. And this 200 or 250, I use it for testing purpose. Why do we need to do this? Because this model that we are building, whether it is going to work or not, we don't know. That is first point. And if I include all the 1,000 points in the training, then on which data points I am going to test it? I can't afford to test it on the real time. That is, this is the house price prediction model that you have built. And then you will ask the customer to test it, or you will ask the end user to test it once. That is not going to work, right? That is not correct way. Without testing, you cannot deploy it, or you cannot send it to the market directly for the final for the usage by the final end user. That is why we split it basically. We split the existing or the available data points into two data sets. One is training data set and another one is testing data set. In many one of the use case like cross validation is there. There we will split it into three parts: training, testing, validation data set. But that we will discuss later. But for now, what you need to know is the available data points are split into two sets. One is training set, another one is testing set for the purpose of testing. We don't use all of it together. That is first point. Next one is once you have the training and test split made or the training and test data set available, then you will start the training. How does the training starts? What is training? What happens during the training is you will take one data point at a time. Let us say this data point. You will take this data point, that is area of the house is 1000, number of bedrooms are 2, age of the building is 7, how far from main road is 2, color of the building is gray, then what is the price of the building? This is what is the question that you would ask to the model. So during the training, this is the model M you have, and you will pass the input variables and ask it to predict output. So this comes out to be, let us say in the first iteration, this first iteration we are calling, what to say? Once you pass the input and ask it to predict, then that is one iteration. And next time when you pass this one, this is second iteration. When you pass 1200, 3, 12, this one. So it will come, it comes out to be output is something like 1000 is the original ground truth value or the actual value, right? So let us say it has predicted 800. Then when it is predicting 800, the model may look something like this. Area of the house, let us say, mm, coefficients, right? C1 multiplied by 1000 plus C2 multiplied by number of bedrooms 2, and otherwise there is no better way. C3 multiplied by age of the building 7, something like this, and equal to 800 it comes out to, but which is not correct, right? So how we are saying it is not correct? If you want to write it programmatically, how I would write is 1000 minus 800 is not equal to 0. That is why I am saying it is not correct. The error, basically it should be equal, both prediction and actual value should be almost equal. Then I say it is perfect. So since that actual value, that is this one, ground truth 1000, and the prediction are not equal, that is the difference is not 0, then I am saying that we need to adjust the weights. We need to adjust the parameters. So this C1, C2, C3, let me write it here. C1 coefficients, C2, C3, C4, and C5. These are the parameters or the coefficients. Then I need to adjust them. C1 dash, C2 dash, C3 dash, C4 dash, C5 dash. I need to adjust them to make it closer to 1000. That is what we need to do. So first pass or the first step where we are passing these values and asking it to predict some value, that is 800, it is predicting. That process is called forward propagation. Let me write it here. in case of neural networks. But here in machine learning, we don't have any such special naming, but you can just remember it. In the first step in training is it passes all the inputs and asks it to predict. And then next step is otherwise, let me make it explicit, passes all the input variable values actually, variable values, and asks the model to predict. Asking in the sense, we'll substitute, that's all. And next step is compare predicted value with actual or ground truth. So if, let me remove all of these annotations. If actual minus, sorry, or GT minus prediction is equal to 0, then move to next data point or next iteration. Next pass we can say, but yeah, for now, let us simplify this. Then model has learned the pattern, or yeah, that is better. And if is not equal to 0, is not equal to 0, then has not learned it. We need to do the iteration. Then what we need to do is adjust weights or parameters. This is what we do. So here, one thing that I want to highlight again is this thing that we are doing, this comparison thing, right? What is this one? Actual minus prediction. This is called error. This error are, write it here, error or loss or cost. All these three words are valid and people use it interchangeably, even though it has a specific purpose, why we call loss, why we call cost, and why we call error. But it is very common that people use these words interchangeably. But most common are loss function, sorry, loss. What is the loss or what is the error? So what is error is actual minus prediction, actual minus prediction. That's all. And how we are coming up with that error is this one. And we try to minimize this error or this difference, actual minus prediction difference, as much as possible during the training. So next step is we try to minimize error as much as possible by adjusting weights. I'll show with some code or one use case later on. But for now, up to this point, it should be clear to you what is happening. What is it? What does it mean by training a model? First, you take one data point, you pass it multiple times to model and ask it to predict. Again, asking the model is not superficial thing. It is simply substituting the parameters. That's all. That wording makes the people feel hard actually in the starting, but that is how it is. You need to handle the terminology. You need to tackle the jargons of machine learning. That's all. People use a lot of this. Again, I'm saying asking the model to predict is nothing but just substituting the values. That's all. You are not literally asking. It is not that way. Yeah. Um, so what we have discussed till now is, let me recap once. Yeah, mainly what are the different learning paradigms in machine learning? That is supervised, unsupervised, and self-supervised and reinforcement learning. So in supervised, we will have the input data points and output data, input and output labels present in the data. And in case if they are not present, then we need to do something else with that data set. That is like segmentation, anomaly detection, or even this what we call it market profiling also sometimes we do that. That is yeah. In case if the output and input labels are not present in the output labels are not present basically, then it is unsupervised learning. Where it went in that Excel sheet. So in case if the labels are not present, then it is unsupervised. These are the few of the use cases that we use unsupervised learning for. That is topic modeling, anomaly detection, segmentation, clustering. These are all the use cases. And supervised, we will have input and output label, input and the output labels are important there. Output labels should be there. And in case of self-supervised learning, there won't be any output labels present in the original data set, but we generate them from the input data that is given to us. That is most commonly used in LLM training. That is one thing. And in reinforcement learning, it is something different. Like there is something called as an agent, where we reward the agent if it does the correct thing, yeah, or correct performs the task in correct way. If it is not performing in correct way, then we penalize the agent. Ultimate goal of the agent is to maximize its rewards and minimize its penalty, so that it will be it in that process of maximizing rewards and minimizing penalties, it learns the thing actually how to play chess, how to move. In case of robotic arm training, it learns how to move the its limbs in optimized way. That is what it happens in case of reinforcement learning. That is out of scope as of now. You don't need to worry too much what is happening inside. But next term comes the training process. In training process, we will take something like each and every. If this is the data set that I have, where I have these are the input columns, and this is the output column. Then I take each and every data point in the input and pass it to the model and ask for the prediction. That is, this is the input data point, and what would be your prediction? What would be your guess? Then it comes up with a guess that is something like 800. Then we need to identify the error. What is the difference that we are getting? What is the actual and what is the prediction? And depending upon that prediction, we try to adjust these weights that we are coming up with. Let me write that equation also here so that it will be clear. Like let us say C1 multiplied by area, C2 multiplied by NB, or I'm writing number of bedrooms, and C3 multiplied by age plus C4 multiplied by distance. Let me write it. Distance from main road. I'm writing in mark plus C5 multiplied by color. This is the this C1, C2, C3, C4 are the parameters, are the weights of the model, and it has to adjust these models, these weights according to the error that it has created, or according to the prediction that it has created. If it is too much, then it has to adjust weights too much. The error is too much, then it has to adjust the weights too much. If the error is less, then it has to adjust less. And one more important thing that I want you to highlight, think about for now, maybe we'll discuss later. Uh, Sorry, I think I had lost it. Let me share it again. Minutes, I will conclude the session. I just want to ask this question and end it. So let us say, can anyone please confirm you are able to see my screen, right?
We
Yes.
can able to.
Yeah. Okay. I we have a model that is x 100 into x plus 200 into, let us make it x1 and x2. This is the model that initial model during some part of training we have come up with this model, and originally it was supposed to be 1000 and we have predicted it as 800 as we did earlier. This is the actual and this is the prediction. Then if obviously here there is some error, 200 error is there, value of error is 200. Then what do you think, which weight I need to adjust here to make it more effective, whether I need to adjust this 200 or 100? So think about it. We'll discuss in the next session. So adjusting 200 will have more effect on the error reduction, or adjusting 100 will have more effect on the error reduction. That is what my question is. Let me write it down. Adjusting, see, let us make it as anyway 100 or will have more effect, is more effective, or adjusting 200. So this is what the question is. You have any questions? I'll stop it here. Okay, the question. Any questions anybody has?
Yeah, Nageshwar. So, do we get this recordings to re-go? I mean, go through it again?
Yeah, yeah, you will get it.
Thanks.
Yeah. If no question, then we will drop off. Thank you.